Welcome back, everybody. We're going to start on Unit 3 now. We're going to talk about access control in our first week. Next week, we'll talk about intrusion detection. And after that, we have our midterm and then spring break. So there's a break coming up in a few weeks. I know, don't look too far ahead, but right now we're going to talk about access control. And we're going to try to put it in the context of electronic access control. Before we get started, though, I got a couple of housekeeping issues just want to go over with everybody. A couple of you have asked about whether I can open up the system to show you what you got wrong on a quiz once you hit submit. If you got anything wrong at all, you want to know what it is, and I understand that you want to know what it is so you can understand it and learn from it. Unfortunately, I can't do that until the quiz closes because we don't all take it at the same time like in a conventional classroom where everybody takes the quiz and hands it in. We could have people who take them, and we do have them that take it on a Monday. When I roll the unit out, we have others that wait till Sunday, and that's perfectly acceptable as long as the due dates are Sunday. It's not a problem for you to wait. You don't lose anything for that. But I can't really open up all the correct answers to somebody on Monday. I trust everybody, but trust and verify is part of my DNA. So I'm not going to do that. But as soon as everybody's done, I will open up those quizzes so that you can go back and take a look. We're kind of getting to what I call a sleepy time in the semester. You came back after your break, and spring is just around the corner, and now everybody's just kind of like, oh, okay, let's get this done. I know we have one or two seniors in the class. I know you got to have senioritis real bad. You got to be thinking about what's next, and what are you going to do when you get out of here, right? So try to really keep your motivation up. I know it's tough. I get that. I go to work every day. And have to keep myself motivated and enthused about work. And we all have days where we just say, "Oh my gosh, I just don't want to do this." But don't let that fall into a situation where you fall behind. In online classes, it's very easy to fall behind during that sleepy time. So keep your motivation going. Keep up to date on everything. With that said, there's no quiz or no discussion this week. So I can see that everybody is just getting ready to hit stop on the lecture because you'd be tempted just to sit it out if there's no quiz this week, there's no discussion, you think maybe you can just wait. Don't do that. This is one of the harder things in the course, access control, because we're going to talk about how it's wired. We're going to talk a little bit of technical stuff, and it can get a little dry, but it's important that you understand it because when you go in to design these systems, you have to consider some of the components that you don't see. Everybody sees that card reader on the wall, and they know they have the card in their hand, but there's a whole lot of stuff that controls it. It's got to go somewhere, and it has to do things. So don't switch off. I'd even think about, since there's no quiz or discussion, and I hate to suggest it, but if you get confused by the lecture, watch it twice, because this is important stuff, and it's going to be really important in the midterm and really important on the final. So don't let up on me, okay, guys? So Dr. Baker and Dr. Benny told us what access control is, and they used a very standard definition, and their definition is correct. It can include key locks, guards, receptionists, even signage. I don't know if they mentioned it, but a sign that says keep out is a form of access control. You're delineating, you're saying this is where you should or should not go. So you are controlling access. But electronic access control systems are normally what we're talking about when we use the term access control now. Even though access control, again, could be gates and fences, you're using all those things to keep people out of a controlled area or making sure only those who are authorized enter. So it's really a screening point of any kind. But for our class, we're going to use a little bit more of a modified definition of access control just to make sure we're all talking about the same thing. And our common definition is very much what is used in industry, and that's why I'm going to use it. Generally in industry, when you're talking about access control, it's an electronic system of credentials, locks, and other devices that allow or deny access to people to controlled areas. An access system will record entry and denial activity for future review by authorized administrators. So when we talk about access control, when I talk about access control, are you going to set up access control in your building? Are you going to use access control in a security plan? I'm really talking about electronic access control, and that is generally how the term is used in industry. So we're going to use it that way in our class. But I wanted to make sure that there was no confusion. Dr. Baker and Dr. Benny were correct when they talk about guards and receptionists and others being part of an access control scheme because they do screen people, make sure only authorized people get in. So technically they're part of total access control. In our limited course, we're going to be talking about access control from the electronic side. So what makes an access system or an access control system unique? Well, first off, it's selective entry. Not everyone gets the same entry on their credential, on their badge. We'll talk about badges at first, and you'll see some other examples of credentials, but a badge, because everybody carries an ID, right, at campus, and you use that to do different things, and many of you use it to get in buildings, right? If we decide that student A can get in a building but student B cannot, we can shut that entry off. We don't have to touch the card. We use a system to do that. We use selective entry so that we know that we can shut one person off and still have it work for another. It's not like taking the lock out and just blocking it or changing the key where anybody who had a key now can't get in. They can be selective. There's also a historical record, and an access control system has a historical record. We can go back a certain amount of time, whatever the amount of time is set, and that is something that you'll need to determine. You can go back and we can see that you went into such and such a building at such and such a time. At least your badge was used at that building, right? We know that. And in order to prove someone was in a certain area, or who may have been the last person in an area, who may have been in an area when something happened that's an anomaly, you need a historical record. An electronic access control system can be integrated with alarms and cameras. By integration, it's simply hooking things together. So I can use a badge, if you will. I can walk up and when you swipe your badge to get into a dorm right now or into a building, that can also trigger a camera to come on to take a picture of you while you're doing that. So now we're verifying that not only was your badge used to get in, but that indeed it is you who is there, because we can match it up with a picture and we know what you look like. We can also cause an alarm if indeed you're not supposed to get in there. And students who work as at the front desk in residence halls will tell you that if someone's not allowed to be in, they will get an alarm on their console, and it will come up with I think someone told me it's a red square or a red lettering around their picture, and it tells you that that person's not supposed to get in. It will selectively not let them in and also tell you they don't belong. You could also set that for someone who is allowed to come in, but you want to understand when they do. Commonly used when you have executives in a building, you would turn that type of feature on so that when the president of the company comes in, the guard just gets a little pop-up on his screen that says, that's the president, and say, good morning, Mr. President. There's no keys with an electronic access control system for the most part, but you have to have some kind of credentials, so you may be replacing keys with something else. You can revoke someone's access without personal contact. If you have keys, and I want to take your access to something away, I must go and get that key or change the lock, right? And now I've locked everybody out. With an access control system, an electronic access control system, I can go into the system and shut you off. That ability to revoke without personal contact is important in these systems. And then you can use the data for other purposes, and we won't get into that so much this week, but think about the many ways that you can understand how many people come into a building at a certain time, can tell you how many parking spaces you may need to have available, can tell you, this is a bad time if you've got everybody coming in the library between, say, 4 and 6 p.m. and they're using their badge swipes to go in there. That would be a really bad time to have somebody come in and clean the carpet in the library because you know it's your busy time. So you can use that data for other, normally facilities purposes, but for other purposes. And that makes these systems unique because they generate data. So if these systems do all those great things and they're better than keys and they can tell you who, and you can lock people out and all those great things, why don't you use them everywhere? Well, cost is a consideration. A true electronic access control system. Now the ones you have on your dorm rooms are a little different. The ones you have on maybe your apartments where you use a key or fob or, not a key, but a fob or an electronic card or something to get in, those are standalone systems, and we'll talk about those later in the semester. But a true access control system, a true wired system that goes back to a console, runs between $5,000 and $10,000 per door to fully wire in if you have no hardware in place to hook to. They're very complex as far as the administration and maintenance. They need to be programmed. They need to be maintained. They have a preventative maintenance program. They're not easy systems. Normally, you need to make a permanent modification to the building, and you'll see why in a minute when we look at a configuration of one of these systems. But it's not like you can just pop it up and not have to drill holes, not have to run wire, run conduit through your walls, that type of thing. And then you have power and network access is required for them, where a standard key, if you have a warehouse out back and you want to secure it, you can put a key on it. But if there's no power going to the warehouse, or if there's no network access and you have a networked access control system, then you're out of luck. So you can't use them everywhere. You need to have normally network access. They can be expensive and complex. So you want to use them judiciously. You want to put them where they really do the most good. So what makes up a true electronic access control system? Well, first off, a credential. You have to present something. It could be a card, as you have. It could be a card you swipe or hold up. It could be a cell phone. Now you can put credentials on cell phones now. It could be your face. It could be any number of things, and we'll list some credentials. You need a reader. You need something that is going to interface with that credential, that's going to verify what it is and tell the system what to do when that credential is presented. You need a controller, and the controller is the thing that takes that data and makes a decision to allow or deny access, or to send in an alarm to say this person shouldn't be here and you need to know it. The controller makes those decisions. And the host is the server or PC or even a laptop on a smaller system that really runs the system and tells the controllers who should and shouldn't be in there. It's the interface where the administrator sits and does all the programming and sends that information to the controller, which makes the decisions. And we'll go over each one of those pieces in detail. There's also the electronic locking device, electric strike, mag lock, two most prominent ones we talked about. There's a few others. There's some crossover, electric hinges, things like that, but those have been used here and there, but for the most part, mag locks and electric strikes. You need one of those because something's got to give, right, to open the door. You need a power supply. You plug these things into the wall, sort of, but they also need backup power to run in case the power goes out, because you don't want all your doors to open up if the power goes out, because I could break into your building simply by cutting the power lines. And need a request to exit device, or a REX. And we'll talk about what a REX is coming up here real shortly. So here we have what's referred to as a riser diagram or system diagram. Normally a riser, you'll hear that term when you're talking to architects. And it shows the configuration of a very basic 4-door access control system. Each one of these doors has an electric strike, as you can see here, and a reader. We'll talk about this button right here in a minute, right? But each one of these devices, right, these are alarm contacts. They look like a mag lock. They're not, they're just big on the drawing. They're really pretty small. I'll show you some pictures of those. But for the most part, let's talk about getting in. You need a reader, you need a strike. And independently, they go back to the control panel. Then the control panel, and there's more than one of them because there's one for every 2 doors in this system. There are 2-door controllers. We'll go back to this host PC or a server or something where someone sits and puts in the information to control these doors, to say who can and cannot get in them. That's the basic configuration. It's a door strike or an electric or a mag lock. It's a reader that's presented, a credentials presented. Both of them go to the control panel. The control panel makes the decision. It uses the information from the card that's sent up this way. And it says, yes, that's a good read. That person is allowed in, and it sends the information back down here, and that goes click, and the door will open. That's simple. Just make sure that everything, you know that everything goes back to the control panel. There is no direct connection between the door and the reader. Most people would think that you present this, that should open the door. It has to go back to someplace that makes the decision, which is right here at the control panel. So the first thing we had presenting to the reader is a credential. Okay, and normally in today's market, it's a card. On campus, you use a swipe card. Other places use different types of card, but it's normally a card. But there's also fobs. One student in one of the previous units sent a picture of a lock on their apartment door, and they use a fob. Theirs happened to be a magnetic tab. I think it was a Schlage device that they had. But a fob is nothing more than something you hang onto your keychain. It's usually a little plastic piece. Sometimes it's a plastic piece with a metal circle. Looks like a magnet on the end of it. And it's a chip. And it's reading and it's giving information to the lock to say this is a good key, electronic key, if you will, or a bad one. And so fobs are good to use too in certain instances. Biodigital devices, so facial recognition, thumbprint readers, hand geometry readers, retina scans, those things that you see normally in the movies or high security buildings where you want to get in, but you want to use something biodigital. That will be the credential that's presented to a reader. It would be a different type of reader, right? That reads retinas perhaps or fingerprints. But the reader is going to look at that credential and decide and send it to the control panel, which decides to open the door. And oftentimes you see keypads used, numerical keypads still used to verify there's a person there, but they have their own problems. But those are the 4 main types of credentials. You know, the card could also be a cell phone. It's the same technology, really. It's sending the same information. It's an antenna type situation. But those are the 4 that you'll generally see. And cards today are still the #1 thing that companies use to get people in and out of buildings for general access. So which of these credentials should you use? And in your midterm and in your final, you're going to have to tell me which credential you want to use and why. So a card can double as an ID because you can print on it, right? You can have an access card, just like you guys have your ID card. On the back, you have a mag stripe. And on the front is your picture and your name, and you can use it as an ID. It requires some administration to print and issue it. So you guys have a badge in parking office, I believe, does the badging, if I remember correctly. But badges are frequently lost, and they can be shareable. There's some risk because they have your picture on it. So you could share your badge with someone, but if someone is watching and takes a look at that badge and says, "Wait a minute, you are a 6'5" male, and this is a 5'5" female's picture here on the badge. I am pretty sure that's not you." There's some risk to sharing, but they are shareable. Now, a fob is usually attached to your car key ring because it comes on a ring, right? So it's less often forgotten. You don't lose it that much. People say they lose their car keys. You misplace your car keys. Very seldom do you lose car keys. I've been driving now for better part of 45 years, and I have never lost my car keys. I misplace them every single day, but I don't lose them. They're always found. And so they're very seldom lost, so you don't have to worry about handing out new ones very often. But there are no visual ID features, so they're very shareable. I can hand my fob to get in a building to anybody, and you can't tell whether it's theirs or mine because they all look the same. They're usually just a piece of plastic, essentially, with a chip inside. Now, biodigital devices are never forgotten. If you're going to read your retina, your fingerprints, your face, facial recognition, you really don't leave those things home, right? They come along with you. But there's privacy concerns when it comes to those. People don't like to give their bio data to their employer usually. They're concerned that if they share their fingerprints, the employer may share those fingerprints with others, including law enforcement. And biodigital devices are very expensive. I just purchased a high-speed fingerprint reader. The reader itself was about $7,000. The project I'm working on is going to install pretty close to 500 of those. So we're looking at $3.5 million worth of just readers. They are the highest security because it's very hard to share your fingerprints or your face with someone else, right? Only in the movies does that happen, but they're extremely expensive and you want to save those for when you need them. And then there are keypads. Keypads are easy. They're cheap. There's no issuance of a credential, really, a hard credential at all. You're just giving somebody a PIN number. But I can share my PIN number with anybody, and if I don't feel like going into a building to get something, I can just give my PIN to someone else. Pretty soon you lose control, and you have the lowest level of security and surety in your system if you're using keypads. So our first component was the credential, a card, a fob, a cell phone, a smart chip, whatever. And now we have a reader. And the reader is the piece of hardware on the wall that the credential is held up to or shown to get the data into the system to request entry. So you can have a swipe or a mag stripe, and there are two different ones. Some swipes don't have a mag stripe. They have a chip inside, an antenna inside, and you swipe it through. And you guys are used to those. You've all been issued one, I think. There are proximity badges, which are a badge that have an antenna inside, and it can be active or passive. It can be battery powered or not. Usually it's not. You just hold it within a few inches of the reader, and it sends the signal to it. That's what I generally use if I'm using badges, is proximity. There are smart readers, and everybody now, their credit card or their debit card normally has a smart chip, and you have to put it in the reader. There are contactless ones too, where you just set it on it. But essentially, a smart reader can it can send a lot of data. It's just not one piece of data saying this is the badge that's presented. It can say this is the badge, and also there are some other things about this person that you should know, like they have the required training to enter the area, or they have the required clearances to enter the area, and that can be loaded on the smart chip to help make an entry decision. Smart readers for entry control are pretty few and far between yet. They've been tried. Generally, the expense is there for the badge, and people don't use them very often to get into those types of areas. So smart readers are there for credit card use, but not so much for entry. And biodigital, facial recognition, fingerprint, retina scan, etc. The big thing is the reader has to match the credential. So you can't use a proximity reader and a mag stripe badge. It won't read it. You can't use a swipe card and a biodigital reader. You can't hold your card up to a retina scan and say, there you go. No, it wants retinas, right? It wants to see your eyes. So therefore, you have to make sure the reader matches the credential. Very important to understand that, because sometimes people will tell you, oh, we want a higher security reader on a building. You say, great, but then you have to hand out credentials potentially to thousands of people. And those credentials, just the badges alone, could run you between $5 and $50 each, depending on the type of badge you use. If you have to do 1,000 of those, that's an expense, right? So whatever credential you're going to use, you make sure your reader matches the credential. Okay, so here we are. Here's our riser diagram again, right? And here's the reader, right? We're going to use this is a swipe reader, just like you guys are used to, a magstripe. Now let's make it proximity. I'm going to give you new badges. You just got to hold them up. And you hold up the badge to the reader, right? So it's a proximity reader, and you have a proximity badge. They match. Now the signal goes up the pipe, right? Think of this as a water pipe, right? Its signal's going up, and it hits the control panel. And let's talk about what happens in the control panel. So the control panel, it's also sometimes called a field panel. You'll hear them called mercury panels. You'll hear them called a lot of different things, but panel is normally in the description, right? Door control panels. They are intelligent panels. They make decisions. So you hold your badge, that proximity badge, to that proximity reader, and the reader now reads the badge, and it gives a series of ones and zeros, and it sends it up to that control panel. And that control panel then goes through its history and polls and says, yes, I have a match for that, and yes, it is valid to come in this door. It makes an immediate allow, deny decision within milliseconds. So the control panel is where the decision is made in each one of these cases. There's about 1,000 to 5,000, depending on the type of panel you have, of the most recent card transactions are stored in the panel. That makes it easier. Think about buffering when I load songs when I'm on an airplane from Amazon. I can't stream, right? Because I'm on the airplane, so I have them loaded in. If I've listened to that music before, it is buffered somewhere, and it comes up more quickly. A website that you visit frequently tends to come up more quickly on your computer because it's buffered in the background. It's remembering where to go to get it. And in these cases, the most recent card transactions are remembered so that it's very quick, especially when you use a door a lot. It just goes back and says, boom, there's John again, bang. Yep, he's good, matches up, and it opens the door. And it sends then power from the control panel down to the electric strike, or maglock, to the locking device, through a series of solenoids and other things, but it sends the power down and opens the door. So the control panel takes the information, the badge goes to the reader sends it to the control panel searches through its data, makes a decision as to whether or not that badge should open that particular door. It says yes, it sends information down, and it unlocks the door. If it says no, it simply rejects the badge, and the door does not unlock. So let's do that through a visual. I walk up right here. I put my badge to this proximity reader, and it says, okay, here's Brian's information, up the pipe, into the control panel, spins around in the memory here, finds my information, says, yes, Brian's allowed in that door. It comes back down this way, down this pipe, and opens up that lock. I open the door, and I walk in. Easy stuff. It makes a decision. It's a yes or no decision in the control panel that tells it to open or close the door. You might ask then, why then do we need a host at all? Well, you'll see here that the host is really what's telling the control panel what to put in its memory in the first place. So the host is also known as the head end of a system. Very common to use that term. So the book and others talk about host. I would use the term head end just equally if you want, because it's pretty common when you talk about your head end. That is a server, a PC or laptop, depending on the size of the system. Mine all use servers because I have thousands of readers hooked to a single system. But you can run them off a PC and a laptop in most cases. And that head end is where the software lies that the administrator puts the data in. It puts my name and my badge number in, and it says what doors I'm allowed to go in. From that host, the control panels poll every couple seconds. The head end shoots information down to that control panel every few seconds, and the control panel is asking for it in a loop, so that every few seconds when I make changes, when I add a badge, when I take someone in or out of a door, every few seconds that control panel gets updated. It's in a constant state of update if it's programmed right. There are some applications where you would only do that once a day if you have a remote location, but in a true, well-planned access control system, it constantly polls. So when you add a card in the system, when you make a change, when you say Brian's no longer allowed to go in that door and take him out, and you type that essentially into the software, You unclick the box with that door name on it, so I can't get in there. It goes down and polls to the control panels and tells the control panels, if Brian requests that door, don't let him in. Okay. It is the interface for the administrator. So the host, the head end, is where the administrator sits to put that information in. Okay. The head end has to have permission levels. And that's really important, even if you have just 2 people, because every access control system, just like any other system, has a system reset on it. And if someone has permissions to reset the system, they can go in and through a series of keystrokes, and it's not very many. It really is a reset the system and are you sure in most systems. They will completely wipe out all of the data in the system to where none of the doors are programmed, none of the control panels are programmed, none of the card holder data is in the control panels, and nothing will happen. You'll be locked out of your building. Permission levels simply set one person as an administrator, someone as an assistant administrator, someone as a user and a viewer only. But it's just like any other permission set in a piece of software. You don't want everybody to have the highest level of permission, because the highest level of permission in these systems can completely wipe it out. So permissions levels at the head end are extremely important. If you are a security manager and you have a technician who is doing nothing but program badges in for people, printing them and handing them and putting their basic information in, you don't want them to have permission to shut the system off. So make sure that your head end is set up with permissions. That's a question you will see again. So here we go. Present the badge. Reader reads the badge, sends it to the control panel. Control panel gets the information, makes a decision, sends it to the door. Now, the host, there's somebody sitting right here and they're typing in, they're saying, make a change. Don't let Brian in that door. Constantly these two are talking. And so this information is dumping to the control panel. And when I hold my badge up there, it goes up and it says, oh, there's been a change, and the door will not open because it will not send the signal down and power to unlock the door. These two are in constant state of talking. Now, what happens if there's a break? What happens if the laptop gets shut off, right? You're running it from a laptop, let's say, and it gets shut off. Somebody unplugs it. The control panel will continue to make decisions based on the last information it got from the host. And that will usually suffice for quite some time. It won't pick up any changes. If this is broken and you don't know it and you're making changes here, none of those changes are going to get to the control panel. So Brian would still be able to get in the door even if you said don't let him in if this breaks. However, you will not shut your system down if your host goes dead. If your control panels have been properly updating and talking all along the way, the system will still run. That's important to know because people tend to freak out when the head end goes down, or they say the head end has to go down for maintenance. I mean, these are running on normally Windows software. And if it's running on Windows software, we all know Windows has to do updates and it shuts down and you're going to get security patches and things. While it's shut down, everything downstream is still working based on its last report. So lots of information here. I'm trying to drum it in, right? So there are other components. The request to exit or REX device, and we'll talk a little bit about those. The locking device, you saw the electric strike, the maglock. We've talked about those before. You understand what they do. So they're part of the components of the system, but you're familiar with those, right? And then power supplies and backup power. So let's talk about the REX device first, right? You know what the electric strike is, so I can not even have to worry about talking about that because you've been over that. You all know that. The REX device would be on the inside of the door. So on the outside of the door, when you walk up, here's your door and here's your reader. You get in and the door locks behind you. Now you have to get out. And unless you have another reader on the inside to let you out, there's got to be a way to get out. You use a request to exit. The request to exit can be many forms, and we'll go over those in just a second. But this goes on the inside of the door so that you can request to exit so that the lock will release so that you can get out. You could do it with a reader on the inside and a reader on the outside. And in some applications, you're going to want to do that because you're going to want to know when somebody went in and when they went out. But in most cases, you really just want to know when somebody went in a room and they're allowed to exit, but they have to use something to unlock the door. So what could that REX button be, or that REX device be? Request to exit device. Well, it could be the push button like you saw in the picture there. So I use my badge. I go in the room. Control panel does its stuff, right? Been talking to the host. It knows what to do. It lets me in the room. I do my work in the room, and now I want to leave, and the door's locked. So how do I get out? Well, maybe I had to push a button. That will release the lock. Maybe there's a crash bar and the request to exit is built into the crash bar. Remember, crash bars are those long bars that go across an emergency exit and you hit them? Well, you can put the REX device right in the crash bar and that'll release the lock as well. Most commonly, though, you use an IR dual technology device, an infrared device that works on motion and heat that will release the door. The big thing to remember is that a REX device releases the door so people can exit. If you don't have it on the interior, it's pretty hard to get out. Let's take a look at a infrared REX. So you may have, in fact, I'm sure every one of you has seen these before. You just didn't know what they were. Back in the old days when I was a kid, when you went into the grocery store, you went onto a rubber mat kind of a entryway. You rolled your cart across coming in, or you walked in, and the door would automatically open for you. And on the way out, same thing. And it was because you had a pressure mat. You walked across this rubberized flooring, if you will, on the inside and the outside. And you'll still see that in many old grocery stores today. But most of them now have a device over the door, and it's usually a little brown box, and it just picks up your motion. And there are motion sensors on doors all over the place. I mean, just about any store, any mall you go into now, you don't open the door for yourself anymore. You walk up and it's a sliding door and it opens because you've walked in front of it. The little difference in the infrared REX device is that it not only picks up motion but also picks up heat. And there's a reason for that. So this is mounted over the door on the inside. Now usually on a door underneath there's a little bit of a gap. If I put something on a piece of wire, a coat hanger maybe, and I slid it under the door and waved it around, if it only went on motion, it might unlock the door. But since I'm not there and there's no heat being picked up, it won't unlock the door from the outside. So you want to use a dual technology REX device whenever possible to open and close the doors if you're not using a reader on the inside. So let's look at this boring drawing one more time. You walk up with a badge or a credential of some kind. The reader is the same type as the credential because it reads it, right? It reads it, it sends it to the control panel. Control panel has a bunch of data stored in it, makes a decision, and either sends or does not send power downstream to the locking device and opens the door. The control panel gets that information because it's constantly polling the host where the administrator sits and is putting information in to make changes, or not at all and everything's staying constant, but it's constantly polling. And you have many control panels, like I said, one for every 2 doors or 4 doors, depending on the size. It could be single door controllers, but all the control panels all come back and they all poll the same way in your big system, right? And then once you're in the room, the door has been opened because the decision was made. It lets you in. You finished your work. Now you have to get out. You have a request to exit device. It's either something over the door on the inside that picks up your motion and heat and unlocks the door for you so you can get out, or it's a palm button that you push, or it's some other type of device that lets you out. Remember, when you're programming, or when you're designing for security, if you are using electronic access control on a door, you have to consider what you're going to use on the inside to let people out. It's one of the considerations, but there are a lot more. So, some of the things to consider. What brand of access control system? Someone told me that Slippery Rock uses Lenel, which is now Lenel S2 brand of access control, so that you can get in and out of buildings. It's a single system for the entire campus, which is good. And Lenel actually is a very, very high-end system. So whoever decided to put that system in at Slippery Rock made a really good decision. I don't know whether it's being used to its fullest or whether it's the most up-to-date version of Lenel or not, but it definitely is considered to be the BMW, if you will, of access control systems. It's a high-end. It's a really good, solid system. You also have to consider who's going to administer the system, so it's going to take time. Now with keys, you issue the key once and nothing changes. You get the key back. But with an access control system, there are changes. People come and go. People want access to doors. Then somebody says, okay, they're done in that area now. We don't want them to have access anymore. Someone has to administer it. That's a consideration. If you're going to put an access control system in, somebody has to administer it. Excuse me. One of the things you need to consider too is, where are you going to put the control panels? Now, you saw those panels on the diagram, but they have to go somewhere. And in fact, in the diagram, if you look at it, the line there essentially is the ceiling, and they can go up in the ceiling. But if you put them in the ceiling and they need a new fuse or they need some wiring changes, things wear out. Now you may have to take the ceiling down to get to them. So you have to consider, where are you going to put everything, right? All this equipment has to go somewhere. you have to consider whether electronic access control is worth the cost. If you're going to spend $5,000 to $10,000 per door to put in a fresh system, you better be protecting something, and you better need to have that history, the things that an electronic access control system does, right? The purpose of it, the history, the idea that you can shut access on and off. If you don't need those things, you don't need that cost. You have to consider data retention. How long are you going to hold data? How much data can you hold? How much memory do you have? In some places, you may need to hold data for longer than others. If you look at the next thing here, it says, will you use the access system for other purposes? Many facilities decide when they put in a card access system, and they tell everybody you must come through this door and use your badge. They say, well, I don't need time clocks anymore. I now have a timekeeping system. But employment law tells you you have to maintain those records for up to 8 years because they're an employment record. Does your system have the capacity to do that, and do you want to do that, right? So, there are a lot of considerations when you put one of these systems in. One of the biggest ones, though, is when you put a system in, you have to make sure that everybody can get out in an emergency. So we talked about that REX device, but that's simply not enough when we're talking about fire safety. An access control system has to allow for free egress in an emergency. So when you wire in mag locks, so think about the mag lock, right? Mag lock is energized and you get inside and the magnet's on and fire breaks out. Let's just say the fire broke out and the place it broke out was inside your control panel. Now, when you walk up to that REX device, nothing's going to happen because the REX device is going back, remember the drawing, it's going back to the control panel too, to say someone's moving inside the room, I pick up heat and I pick up motion, and so can I open the door? And the control panel opens the door, right? It's not connected direct to the door, everything goes to the control panel. Suppose the fire's in the control panel. Now the door won't open. You have to have a way to open that door. Access control systems using mag locks can legally be connected directly to a fire system, so that when someone pulls a fire alarm or smoke detector, a damper detector, any of the other types of smoke or fire or heat detection go off in a building, the mag locks will drop out. The power will drop to them and the doors will open in an emergency. But they have to be independently wired to the fire system. You can't do it through some sort of a software programming. They have to be wired directly. REX devices don't meet that requirement. So if you are using mag locks, you have to understand the fire code and you have to make sure you have a fire code qualified fire technician come in to do those terminations so that somebody can get out. That's why when we talked about mag locks and electric strikes seem like they have a lot more moving parts and you have to cut the door, right? And we talked about that. You have to cut them in. Where a mag lock, you can kind of put it up there and bolt it on and it seems like it's the easy way to go. Well, it is the easy way to go, but you also now have to worry about egress. With an electric strike, that crash bar is going to open up, right? You're going to push on the bar and it's going to open up. There's a way to get out with an electric strike. With a mag lock, not so easy, must be wired to the fire system. So when you design your building for your midterm, right, when you start talking about access control, and we'll start to design that soon, if you're going to put mag locks on the door, you're going to have some indication, and there will be a cost to that. So you may want to think about electric strikes before you think about mag locks, just for that single reason, is that you have the cost and the complexity and the responsibility to make sure that egress is taken care of. So let's talk a little bit about new systems that are coming out. And it'd be really easy for me to just tell you about the new stuff, but chances are when you hit the field in between 1 and 4 years, depending on what year of school you're in, you are not going to get a brand new access control system anywhere. Access control systems in the field normally have a life of an obsolescence of 10 years to 15 years. It is very unlikely you're going to have a brand new system in any building that you happen to get to. And I will say that companies that don't have a huge security mission, where you don't have high priority resources and are using this simply for, to let people in and out and keeping a record of that, will sometimes let these systems run for 20 years or more, simply upgrading and updating the software, updating the license, putting patches in to make sure that they're secure. But you're not going to get a lot of new components. So I wanted to go over a lot of what the older systems look like, which is what we just did. But new systems are coming out all the time, and they're wireless from the control panel to the host. Wiring can be very expensive in a building. Running wire, because you have to think about a commercial building full of wires already for your computer systems, full of pipes for your plumbing systems and heating and cooling. up above the ceiling in a commercial building, if you look at it, it looks a lot like spaghetti. And you don't want to add more to that. So there are new systems that are running wireless from the control panel to the host. The readers can be wireless to the control panel. They normally operate with a booster for long distances. If you look very closely at that drawing, I think that the RS cabling that they had in there, 485, runs about 4,000 feet. That's not a long way when you're talking about a large commercial warehouse or building. And you need a booster for those long distances, but that can work. You can use a wireless booster. But outside the U.S., there are problems with wireless boosters. I bring this up only because I tried to do it in Stockholm about a year or so ago. I was going to do everything wireless because it was a cheaper way than running all the wire, and got shut down because the radio frequency to operate the wireless was one that was already in use, and there was not one available. By law, they regulate which frequencies you can use, and I didn't have one available, so it was a non-starter. There are definite cost advantages, right, to wireless stuff, because running wiring costs a lot more money, and wires break. They definitely have some vulnerabilities, though. Power and signal loss. You know, how many times have you been somewhere with your cell phone or your computer and you say, oh, I lost the internet, it just dropped out. Or, you know, I don't have a signal, I'm down to 1 bar, right? And then there's also some cybersecurity stuff. Whenever you talk about wireless, you are opening up some cybersecurity concerns. A fully wired and contained system is much easier to control. But look, the new systems are all going wireless. They are more coming in a box that you can put up without having to run much wiring at all, and that's a very good thing for us. So when you talk about putting up a system, adding readers and things, you should start to think about, can I do this wirelessly? You'll see that happening more and more. So to finish up this particular unit, and then I just have a couple more slides on some housekeeping stuff again, you should know the definition of access control, both the book definition and our definition. You should know the components of access systems, and realistically, they were credentials, they were readers, they were control panels, they were door hardware, they were host, right? That was about it. What makes access control systems unique? Why you would want to use them, right? It was in one of the early slides. Understand that, remember those things. What credentials are best to use for an application? You don't need to memorize that, but I would use that slide as a chart. You know, when we talk about I want to use a fob, well, okay, if you're going to use a fob, just remember that there's no ID. You can hand those off. How important is that to you? If you don't have somebody around that's going to, make badges when people lose them, a fob may be the way to go because they're normally attached to car keys. But think about the type of credentials you want to use for a particular application and what else that credential might do for you. Just remember the importance of permission levels. You don't want a lower level person that has access that's working on your system, monitoring your system. You certainly don't want them shutting it down. Understand why a REX, a request to exit, is important, because if you don't, you're not going to get out of the door. And remember that emergency egress is the most important. Don't ever forget this. This is the one thing that can get you fired and put in jail in this field, and that is that you can't lock people into an area. You have to have a way to get out if indeed that fire alarm goes off. So always remember that. With that, let's talk about a couple of housekeeping issues. So as I said, we're going to apply everything we learned this semester to an actual design of a security plan, a physical security plan. And I sent, this week, I posted to the course shell, there's an open unit called Floor Plans, and it's got a set of information on it. Read it over and start to think about the lock sets for those interior rooms. And I think they're pretty basic, quite frankly. Look, you've got an office, you got 2 offices, you've got a break room, you've got a conference room, you've got a file storage room, and I sent some information about the file storage room, and you have a big warehouse area. Think about the door locks on those interior doors. What type of lock set would you put in there, right? We went over the different types. Does it require a classroom? Does it require a storage room, a classroom security, a passage set, a privacy set, office set? What does it require? And then think about why. And if you want to get ahead a little bit, you can go ahead and do that, and then write up just a 1 sentence as to why you chose that. And just keep that handy, because we'll have those to plug into the beginnings of our security scope document. Okay? You're going to submit a version of that floor plan with the midterm, and it's going to have some basic stuff on it. And you're going to submit a final one with the final, and you're going to have it almost done several times, but just as with any real-life engineering project, there will be changes. They will change the way a room is going to be used. They will change the budget. You get notifications all the time from an architect. We've had a value engineering session, and we can no longer spend $100,000 on security, you're only getting $50,000. So you need to make decisions as the security manager as to what's most important, whether you can change out from electronic access control, which is going to be $10,000 a door perhaps, to something different, to a lock set, which is going to be included in the base building, right? So you're going to get a budget for the final, but for the midterm, just start to worry about the locks, and then we'll start on lighting and other things as we get a little closer. Okay. I also gave you some information, a backstory. There's really not a warehouse. Sorry, gang, there's no warehouse jobs coming to Butler County that I'm aware of, at least with this project. But I gave you some information that the company, those are two real companies. Constellation Brands is a major holder of stock in Canopy Growth, and they're using this warehouse to store products that come from Canopy Growth. I'm going to make you go into the internet, if you haven't gone already, and determine what types of products might be stored in that building, because it might give you a general idea of who your adversary is. We'll start to use that predictive model about who might want to come in and why they might want to come in, and where you want to have your higher levels of protection. So take a look at the floor plans. Since there's no quiz or discussion this week, you might want to go ahead and just start thinking about the lock sets that go on to the interior doors. Look at the exterior doors a little bit. And after we do next week's unit with intrusion, then we'll start to talk about intrusion detection and electronic access control if you decide to use it on the building, and where you might want to put that stuff. So this week, you read text chapter 7, page 97 to 108. Hopefully you did that before you got started. Print out the slides for the lecture so you could take the notes. You did all that good stuff, and you completed the lecture. You just did it. So on top of just kind of looking at those locking devices and kind of, thinking through it, you don't necessarily have to do it. I'm not going to ask you to turn it in next week, but you can get ahead a little bit. But I also want you to look around campus and other places for access control devices. Start to look at card readers when you see them places. Do they have the right device? What type of recs do they have on the other side? What's telling that system that you're leaving, if anything, that you can see? And again, did they do it right? Just as we did with the lock sets, did they hook it up right? Does it appear to work the way it should? And would you do something different? Just think about those things. It's good practice to look at this stuff as you walk through the field. I'm always looking at doors when I go places. If I see a card reader, I can't help but go up and start to look at it. And I usually have a card in my pocket, and I run it to see what happens, because it shouldn't work. But you never know. It's kind of like driving through a subdivision and pushing your garage door button just to see if you can open anybody's garage, just for the heck of it. Perhaps I bore easily, but start to look at this stuff as you go around, because you'll learn an awful lot about the way things are hooked up and how they're hooked up badly, so that you can learn from those mistakes in the future. With that, have a great week. We're at 47 minutes, about 2 minutes over from my optimum. I will be around all week. If you need anything, please contact me. Thanks. Bye.